But also some students have already sent me the homework. It is good. And at the end of this lecture, I will repeat it again. However, remember well that send me anything via email. It is better because I can read it and answer it in my free time. I have many other duties. So if you send me for example, via team, and so also I cannot check it all time. It is better to send me via email. Okay, here it is my email address. And also, if you send me, please send me not to the team, not to the one driver or something. If you have some many problems, so please compress it and send me. Okay. Normally, I'm sitting on the C1 2 to 4. If you have any problem, for example, if the problem with your study, you can ask if I can, if I have the answer, or I can ask other people to help you. So don't be afraid. So not only send me the question, not only about the mechanic, but also the of problem in the other our university. Okay, is it too slow? So let's start. Okay, so some recording. What is this? Okay, so I'm waiting to be recording. This picture, I said to you that I will show you many times because it shows not topic, not only for this semester, but also not only for this semester, but for the second semester also. You see again that this in this picture, you see the topic for this semester and the second semester. The topic of mechanics is to specifying the relationship between force and the motion of rigid body. Okay. However, in this course, you will specify, or we are interested only in one special case of the motion. It means that equilibrium. It means that the rigid body or the system of rigid body does not move. It is equilibrium. The rest is a special case of the motion. Okay, so in this case, because it is no motion, so I don't take care about the velocity and acceleration and so on. I take only the forces. It is the region of everything in the equilibrium. So it is the topic of the this first semester, the static one. In the second semester, we are dealing with dynamic. Dynamic is split it or is exploded in two part, kinematic and kinetic. In kinematic, we deal only with the motion without any explanation or the reason of this motion. It means that I don't take care of the force. So you see that because I don't take care about the force, I study only the motion. So in this case, you see sometimes you call it geometrical. I observe it, I measure it. I don't take any any region. Only in the part of kinetic, I try to specify two things: forces, which we have already studied very carefully in this semester, and the motion if we are dealing with the kinematic one. So kinetic is a more general or most general cases of dynamic. So see again, this picture all the time I show it many times. In the advanced course of mechanics, you have two parts, static and dynamic. However, if we read the textbook in Vietnamese, I saw that many students take a reference like in Vietnamese textbook. So you see that at our university, Vietnamese students study in the first course static and kinematic, and later in the second course they study kinetics, or sometimes they have only one course. However, in advanced course, we study in 2 semesters with static and dynamics as over the world in anywhere. Okay, so you understand. I show it this picture for you to see why we have this problem, why we have this course, and so this picture I will show you more and more time. And because we are studying with the equilibrium of the all rigid body, so you will take first thing, Fock system. One thing very important that we are speaking, when we are speaking last time, we have already emphasized it. When we are speaking about Fock system, we assume that this system of many forces acting on only one rigid body. Okay, remember well that one rigid body. It means that we have only one rigid body. Later, we can extend this result to the system of many rigid body, but with with many assumption. Okay, so remember well. But the basics of Fock system theory is a assumption that any forces acting on the one rigid body, absolutely rigid, no deformation. Okay, so and in this chapter of Fock system, on this theory of Fock system, you will do many things step by step. Today we started with last time we have already defined Fock vector, and we have already calculated resultant force. And today you will calculate the second characteristic, very important characteristic of Fock system. It means resultant moment. For one Fock system, there are two things very important. First one is a resultant force. The second one is a resultant moment. Okay, resultant moment. And these two things give us the opportunity of the change to reduce any complicated Fock system. For any complicated system, you should, or we together should reduce it to two things: resultant force plus resultant moment. And with these two things, you can define, we can see, or you can check if this system is in equilibrium or is in the motion. Okay, do you understand the philosophy and why we do it and what we are doing? So first thing, force of vector and resultant force we have done last week, and today we start with the resultant moment. And first thing, before finding the resultant moment, we should define a moment. What is the moment? And so on. So some repeating from the last time. Resultant force of any forces. But last time we have concentrated only a Fock system with the concurrent forces. Why? Because with today, when you will define moment of forces, so you can define resultant force of any general forces. However, without the defining the moment, we are able at this time only you can define a resultant force of moment of forces which are concurrent. Okay, for example, I have many forces F1, F2, Fn, and they are concurrent. Surely, okay. Later we'll extend this for other arbitrary forces, and all forces are represented in the algebraic or Cartesian coordinate system with Fx, Fy, and Fz. And resultant force can be specified or can be calculated by taking summation of all forces. Fr as FR stand for resultant force. Okay, Fn for summation, for calculating summation of all forces, you can do with two methods. The first method is a so-called drawing method. Last time we have already shown the third axiom, third basic law of static is a parallelogram. So if we take a step by step, for example, F1, F2 can be replaced by one diagonal on the parallelogram. So after that, I take this diagram, diagonal with the third, and after that, you can complete it at this drawing program, the drawing diagram, like here. For example, I have three forces. So you see that if I draw parallelogram with F1 and F2, so I have one forces. And after that, I take this force with F3 parallelogram again, so I have a resultant force. Okay, but it is better, instead of drawing step-by-step parallelogram here, I will do something like this. I fix some point here, point 8. And from this point, I bring F1 from here to here, parallel, and bring here. And at the end point, I will draw F2. I bring F2 here from origin position to here. And you see that if I draw parallelogram with F1 and F2, so I get one diagonal here. So after that, if I bring F3 here, so I have another parallelogram. So, but it is no need to draw parallelogram. It is enough if I bring in parallel way F1 to here, F2 here, and at the end I bring F3 here from the origin picture here to here. And now the vector closing this polygon give us the FR. I can prove it very easily by parallelogram. Okay, so it is a so-called drawing method. Last time we have already shown it, but it is better because with the computer and mathematics tool, you can use the second method, so-called projection method. It means that each force I explode it into three components, X, Y, and Z, like here. Okay, and with these three components, I provide summation in X direction, in Y direction, in Z direction, and in these three components, I calculate resultant force. Okay, and with this vector, I can calculate very easily the magnitude. You see again by using Pythagorean theorem, and also we can calculate the angle. Oh, sorry. I check it if you have already required recording. Too slow. Wait a moment. Okay. With the we have somebody have already recording. Thank you. I forget. I have the problem with my second computer, so I cannot follow what happened on the second screen. So it's good that you have made a recording. Okay, we continue. With the direction, with I have a total vector, I have component, so I get cosine and the unit vector, or also the angular sine and cosine also. Okay, here you see. So it is from last week, and total overview for all of you to see it. And now again I repeat it, that important for Fox system that I should calculate two things: resultant Fox and resultant moment. Resultant Fox we have already done, we have understand well. Okay, and just now today we'll start with resultant moment. What is good for? With these two things, I say that any Fox system, any complicated Fox system can be reduced. And with these two things, I can provide analysis if they are in the rest, in the what do you say, in the equilibrium, in the rest or not, or in the motion. Okay, so step by step. Resultant Fox is a finish. We have already done it. And now we start with the resultant moment. First thing, we will design what is the moment. Might be something you know it from the high school, from the physics, and also anywhere. But today, we will start it again. Moment of a fox. Two things. About what? A fox, moment of a fox, but about what? About a point or about an axis. First thing you will define, oh sorry. Sorry. Okay, so we will start to specify the moment of what? Of a fox. About what? About a point or an axis. First thing, you will define a moment about a point or an axis. And after that, you go to the what we have already defined, that calculate, you will be able to calculate the second important characteristic of the Fox system, resultant moment. And after that, you will specify the special case of of Fox's moment and calculate the resultant moment and coupler also. Okay, so go to the topic today. Moment of a Fox about what? About pi. About an axis, we will define later. At this moment, you will specify moment of a Fox above some point, above point O. Thầy, at this moment, you will define by using scalar analysis. It means that anything will specify in the one plane. Why? Because if I have one fox acting on point A and one point O here, with one line and one point, you know from geometry that all the time you can define one plane. And this plane is the plane of the paper or the blackboard or the plane of your screen. So in this case, I have fox F, point A here. And in this case, I define the moment of a fox F by this product F time distance D. I measure distance D in the plane what I have already defined from point O, or from off this line from point O. Okay, so in this case I have F time D. You see that here I have the sign plus or minus. It is quite easy because the moment all the time give us, the engineer, the imagination, the picture of the tendency of the result of rotating. So you get fox F here acting here. So you see that I have on this fox F give the body the tendency to rotate above point O in this counterclockwise direction. And counterclockwise direction is positive. So in this case, I have MO is a plus or positive FD. So vice versa, if I have F for F here in this direction, So you see that the force F gives the rigid body the tendency of rotating clockwise. So in this case, you see that it is a minus. It is minus. So here in the definition, in the scalar analysis, I have a plus or minus Fg. Okay. Too slow. Okay. So again, I say again that the body of the structure, later you see clockwise or counterclockwise, all the time pay attention. Either in the example you see today, that you have a positive one or negative one if it is clockwise or it is a counterclockwise. So even I have here the scalar one, but you see that if I have any other foxes, but they have the same magnitude and the same direction, and it is equivalent. F should be the same or the same effect if they produce the same moment. Okay, it is only one note because beside of a fox, just now today we have already taken into consideration the second thing, the moment of this fox above a point. And later you will see in engineering career in the future, you see that if I use the scalar analysis, it is not enough. It is too easy. But in the engineering career, you see that you should take many more complicated problem. In this case, it is better to use a vector analysis, vector definition, how you can define it, step by step. This vector, you can see here, I have a fox F, I have a point O here, and I can define the vector of moment of fox F above point O like a vector, and this vector is a perpendicular here to the plane containing point O and line of application of F. Some minutes before, I repeated again that uh, uh, with the one point and one line all the time, I can construct one plane. And some minutes before in the in the slide, previous slide, you see that I have already, I draw everything in the plane. So here in 3D picture, I see I have the plane here, and I construct one perpendicular line to this plane. Okay, and the direction of this moment vector is using by right hand rule. You see here again. If later you see, but at this moment you can see that the rotating of the tendency of rotation of the fox above point O here using by my right hand finger, and the thumb here will show the direction of this vector. Later you see I have the vector R and F, you will see, but at this moment look at this, I have F and I have a point O. The tendency of the rotation is surely in this direction. Okay, it is quite clear for you. And now I use the right hand, and the finger, the curling of my finger will show this curling, and the thumb will show the direction of this moment. Okay, so the direction, the the direction is the line, and now the magnitude. The magnitude can be specified very easily. In this plane, I draw or I measure, I calculate the distance. So you see that d times f, like previous one, can be defined by r sine theta, where theta is the angle of position vector of any point of line application, in this case point A, from point O. In this case, I should extend it from positive direction of the vector R to the positive direction of F. Look at this picture. Look at this picture. You see here again, FR here and vector F here. So I should extend it to have the positive direction of the first one, vector R, to vector F. So using again the right hand rule, so you see the thumb will show the positive direction of the moment MO as the previous minute before. And now you can write it in the mathematical way. Here again, I have the force F in Cartesian coordinate system. I have position vector R, okay, in here, F, point O, and position vector OA, okay, OA here. And now the definition of moment, vector moment, a moment, or a vector of moment or moment vector of a force above a point can be defined by cross product. Remember where cross product, okay, cross product with the position vector R times F. Because it is a cross product, so it is very important is the order of these two vectors. The first vector is a vector R. Second vector is vector F. By using this definition, by using mathematical operation, so I can use this determinant. On the first row, it is what? It is a unit vector I, J, and K. Second row is a position component, okay? And third row is a component of force vector. So after that, you can calculate this vector here. Okay, it is very important. Remember well that this unit definition is can be calculating by cross product, okay? Because some student later ask me, why don't you use other product, for example? It is only mathematical definition. It is a definition. I say that cross product, that it is cross product, okay? With using this definition and using the mathematical tools, so there are many advantages. And now we go to the first game for today, quiz. Okay, we are dealing with many quiz later. If with the COVID situation, maybe we go like in the last semester, you should do online examination. So during the course, it is better if we go to have offline, but step by step, or from time to time we have some quiz. Today we have one quiz and many examples. So the quiz, after the quiz, you will write the answer to the chat room, okay? Write the answer here. I have some problem with the write the answer to the chat room. Okay, so I will show. Oh, sorry. Write too slow. Write answer here. Let me check it. Like a 1B, 2C or something like this. Okay, I send you the chat room. So, two questions. First thing, second thing. First thing, you see that I have a 4 position of a force F. Okay, in position P, position Q, position R, and position S, all explain the position of Fox F, and try to specify which position give us the maximum and minimum moment to this knot. Okay, and the second question the same. It is like here. Okay, some minute for you. This time I will check again the. I restart my computer. Okay, wait a moment. Wait me a bit, okay? I resolve my problem, but yeah, we have a time for all the people to check the first quiz for today. All your activity will be classified and have some effect on your midterm assessment on at the end of the semester. Okay, good. Enjoy it. Today you have a lot of problems. Example, you have a time to join the lecture. Not all of you give the answer. Wait a bit for all the people to finish, and I also to check my second computer to have the better contact with you. It's better. It's too slow. I cannot contact with you here. The Wi-Fi has the problem. Too slow, too slow, too slow. Okay, I cannot wait for it is. I cannot contact with you here. Too slow. It is too bad that today I cannot contact with you here. Second. Okay, so I can wait. Because my problem, the Wi-Fi is not, so I cannot contact you via the second screen. We are waiting, but okay, it's better to refresh it. So while looking for the second, at this time you can see that the correct result is 1D. One is D. Why? You see here, surely that the perpendicular line here to give the point of the maximum moment, because it is a big distance of the the biggest distance from Q to this point. Okay, and S also because this point of application as the line of application passing through to the node. So surely D is the correct answer. And the second one is good also because if I yes what
What are PQRS?
what
What are PQRS?
Oh, Mr. Usama, it is too late. It is a position of the fox. It is direction of all the foxes. Of F, I have already explained it. And just now it is the only answer. You go further. You should ask me before, some minutes before. PQRS, it is the position, the definition of the position of these foxes. Okay?
Okay.
Next time. Because let me see. Later, you ask again, your friend, you will explain it. PQRS only is a position. No, I have no time. You should ask her before. And no, come back again because I don't have the second picture. I can know what happened with the chat room. I am restart again my computer. But we go to the continue with lecture. It's the second second question. You see again, it is a definition of the moment of a fox. Okay, it is cross product, and with I have the cross product, it means you know from the physics or from the mathematics, if I have cross product of two vector, and this vector is a perpendicular to the plane. What some minutes before we have already shown it. Okay, and it means that if it's perpendicular to the plane containing F and R, it means that it's perpendicular to R also. So in this case, if I provide a dot product, so I have 0. So okay, 1D 28. This is quite easy for you. Okay, so it is only training. It is not so. Remember well only this definition. Here, this first one, I use as a definition in vector representation. Is the first example, as the first question for the quiz. You can use a scalar representation. It is better to imagine the question. Okay. So, and now we will go to the example today after the quiz. Very easy. However, again, I saw that even many students give correct answer of this, but some students not. So for starting today, we have a lot of examples. This one is the first for today after the quiz. Take a paper, calculator, and pencil and try to find the result of this first example. So do it. I give you some minutes and I can go to my computer to see what happened. There are many ways to do this example because it is planar cases. So it is very easy that I can use the scalar analysis to specify the distance of fox F from point out. It is the first method. The second method, either to find using the vector analysis. It means that I can explode fox F into two components, Fx and Fy. It depends on you. Which one is better for you to calculate it? Because if I explode fox F in two components, Fx and Fy, so I can calculate these two components, the distance of these two components from O very easily. Okay. Here is the plan. In this case, I use the second method. I resolve the force f in two components, component fx, component fy, and after that, calculate the distance of these two components to the to point O. Really, we have the problem with the Wi-Fi. Oh, it's better. It is now I can see you. Two problem, many problem with the Wi-Fi, and you see. Oh, I see. Look, I'm sorry. That's now I see that many good students have already the result. I check it. Do I vote? It is better. Finally, I can see you on the via chat room because the first screen I used. Good. Now I see all of your result. Good. Somebody has, nearly all of you has a result. Okay. For 160, somebody uses the sign plus or minus. Somebody say clockwise, somebody no clockwise. Good. Very important that for you, that if they require it, you should have the result. And show also the direction of this moment. You see the tendency. You understand the physical meaning of this. You see the tendency of the the tendency of the rotation of this rigid body. Surely it is very clockwise. It means that's minus. Okay, so you see that somebody have plus or somebody of the minus. So you see how you can do it. In this case, I explode it or I resolve it in two components, X, Y, and Z. Okay, but pay attention again that in the English textbook, many times they use this form. You can see here, 3, 4, 5 to describe. So describe the describe the orientation of the line. Normally, Vietnamese textbook, they give you angle alpha, beta, gamma, and so on. Okay, but in English textbook, in many times they give you 4, 3, 5, and so on. So here you can have the two component fx and fy here. And after that, because if I have fx and fy, I calculated very easily the distance of this component from point O. So from that, I get this result. So the correct result is what? Minus 460 minus, and also something like magnitude 416 and clockwise. Good. Okay, it is only the first example, the first try of you. Okay, good. Continuing. Just know it is better. I can contact you via the chat room. So finally, the Wi-Fi is okay. Sometimes it is a problem. So the second one is more complicated. Just know you have 3D problems. 3D problem. In this case, you cannot find easily the distance of component like the first one. So think about it. What you can do it. How you can do it. In this case, it is better to find again Fox F and position vector of Fox. Here it is point of application C over point A. We can calculate it. And also using the vector definition. So it means that I use a cross product of this. Okay. So in this case, it's not so simple like first one. So do it. I give you some minutes before. Like some minutes before. Good. Oh, I see. The first result. Good. But we are waiting for other. Okay. Mr. Pham Thế Long. We'll see if it is good or not. No, why?
I forget to calculate F and RAC. I only calculate M. Oh,
Okay. See, you should calculate not F. You should
yes,
calculate
I had
moment
to,
of F.
but
Okay.
I
Here,
forgot to note.
F and later with this F, you should calculate the moment. It is F. I don't know why F. You should calculate the moment of F above point 8. Here it is first result. Okay, the first result. Really, somebody have a Fox F, but the final result should be moment of this Fox above point 0. Okay, you see, Mr. That good. Because I use a mathematical tool, so in this case, I should use the determinant by cross product. You will see. But okay, I will have some remark, Mr. Hoàng Việt Anh. Okay, you will have some remark about your result. Good. But you see, in this case, that the results are quite different from each other. Oh, I made a mistake. Okay, you see, it is not so important. It's good that you have a deal with the example. At this moment, it is not so important. If you are wrong or you have wrong, important that you know where is your mistake, your error. Next time you don't do it because only one forever. All the time it is important that you join this example to do it. And next time I hope that you will. Okay, you don't have any. Mr. Hoàng Việt Anh is better. Good. Mr. Dũng, it is not correct. Look at this at the slide. The correct result I have already shown. Also with the also with the sign. Mr. Tiến wrong also. Try to
Yes.
find where maybe it is the wrong with the calculating of the you see here determinant. But okay, don't be upset. Don't be sad that you don't have the good result to them. This before you remember well that you see again, Mr. Quang Tiến from the side make the wrong result. Important that you know where the error. But One important remark from me to you. Look, for example, if you had chat room here or in the result here, because I don't know what you are, what are you doing. However, pay attention that at this result, all the time I have three significant digit. If later in the test or in the quiz or in the final examination, we have online, and the machine will classify your grade, your result. And if you have not enough or too so much or not enough significant digit, so it can be specified like a wrong result. Here you see again, you see here I have a three significant digit. Take for attention. Look, if your some your friend sends the result to the chat room, so I see. For example, Mr. Tạ Anh Dũng, you have three components. One component you have three significant digit. The second one
I
has
calculate
four.
the first component.
So it is, pay attention to this. It is not so normally if you have the result on the paper, I don't care. Okay, it is even it is important for engineer. However, it is especially important for you if this result will be classified by machine, by online. It is automatic. Okay, the same for Mr. Hoàng Việt Anh. You see that something you write is a two significant digit, something you write is three. Okay, pay attention to this. It is the last remark of me from me to you. Okay, and now we will continue with the second portion of the moment of a fork. I say that moment of a fork above what? Above a sign, above an axis. And just now you will go to the moment of a fork above an axis. Look at this picture. If I have, for example, this axis, and I have this bracket, I want to rotate this rigid body above this z-axis, and I have three position direction of force. F in this case, F is in each direction. So in case that normally the engineer will do it, I want to rotate this one. However, if I want to rotate it above this, I add force in this direction, so I cannot rotate in this axis anymore. In this case, the rotation is above this z-axis. Okay, it is a wasting force. And here, for example, if I have a force in this direction, I have no rotation anymore. Not either above z-axis, what I want, neither above z-axis. This picture gives us some picture of imagination about the moment of a force above an axis. How we can do it? Here is this geometric picture. I draw it again. I have a force F here, okay, very in general case, and the axis delta. And now I want to calculate the moment of force F above delta. It means I want to calculate the tendency that force will give to the body to rotate, the tendency of the rotation. Okay, look at this picture. This the first one, I know the tendency of the of rotation quite very easily, that I can imagine this rotatable this axis. Here, the second picture gives us the tendency of the rotation above x-axis, and this one is no tendency above this point. Okay, so apply, come back again to this picture. If I want to calculate the rotation, tendency of rotation of above this axis, I can do something like this. I resolve this force in two components. First component, F1, is parallel to to the plane which is perpendicular to this axis. Second one is parallel to this axis, or in other words, I will resolve this fork into component. First component is parallel to delta. The second one is in some way to perpendicular to the delta. Okay, so you see that F2 is parallel to delta, so it means that it does not give any contribution to the tendency of rotation. So F2 is wasting. Nothing happened with F2 with the rotation. And F1, I can imagine that F1 is a projection of F to the plane which is perpendicular to the axis delta. Okay, do you understand? I draw the plane perpendicular to the delta, and I project this F into this plane. And now clearly I see that F1 gives the tendency to rotate the body above this delta by, like some minutes before, I have only defined by using the moment of F above point O. It means that F times D, and I can define it like a vector along this line. Okay, do you understand? So, conclusion. I can define the moment of force F above axis delta, which denoting by M delta, is defined by the moment of F1. F1 is one component above point O, above this point. And what is it? What is the F1? F1 is a projection of F on a plane P. Okay. This plane is perpendicular to the delta. And with this plane, I have the intersection point of this with this axis. So I calculate the moment of F1 to this point. And this gives us the moment of the origin force F above delta. Okay, and in this case I can write by using the previous definition of F. So you see moment of F above axis delta is the moment of component F1 above point O, where F1 is the projecting component of F into plane perpendicular to the axis, and O is the intersecting point or intersection point of delta with the constructing plane. Okay, and the rest is quite easy. F1 times D. It is a scalar analysis. However, it is better. You can do it by using vector. But at this moment, you see at this picture again, if I want to calculate the moment F above y-axis, this one, so I can calculate very easily. I use I draw the plane, okay, with the F, and I draw the perpendicular line, the plane to y-axis. It means that HZ, and from this I can calculate a very easily moment in this side above point O. Okay, and so you see that I calculate in this case I can calculate dx very easily. However, for more complicated case in the engineering career, dx this arm is not can be found very quickly. All right. In this case, I don't use algebraic or scalar analysis. I use a so-called vector analysis. It is better for you. How we can do it? It's the same like some minutes before, but I use a mathematical operation. So look at this picture again. I have a axis. In this case, I draw it like axis 8. I have a force F in the very general cases. Okay. And in this case, first, I will calculate the moment of this force F above some point O. Point O is lying on the line A. Okay, you know it. Some minutes before, you have all some example. I calculate the moment of force F above point O using cross product. Okay, any arbitrary point O you see here. So MO is R times F. Okay, and after after finding this moment MO is a cross product R times F perpendicular to the plane here. And after that, I project it into this line by using dot product. You know from the mathematical course that the projection of one vector, in this case vector MO, to the one line in some direction is a dot product. Dot product is a product of this vector and unit vector of this. So in this case, I have moment MA, like a magnitude or scalar. Okay, so cross product for finding the moment of F above point O. And I have a vector. After that, I use a dot product to find a projection on A, okay, on axis A. Again, conclusion. First thing, I have a F, okay, I have a point O, and I use moment of F above point O by using cross product vector here. And after that, I find a moment F above axis delta by using cross product. Cross product. For cross product, for dot product, it is not important the order. So you can write the MO before or after the bracket. Okay, this one sometimes in the mathematical they call triple product. It means that I have a cross product and I have dot product, and they call it triple product. So in this case, I have a delta here. It is a projection of MO into delta. Okay. So here, triple product can be defined in some way. Here it is a unit vector I, j, and k, when and with the 1, 2, 3 unit vector, and here it is a vector of moment above a point. Okay, and after that I have triple product. In very nice thing, I have three things. In the first route, it is a component of a unit vector UX, UI, and UZ. Second component is a position vector of from A to O, and the third route is a component, three component of FH. Remember why this thing. Okay, and from this we have one remark. Very important. That important because sometimes it saves your time and effort. If force F is a parallel to delta, or the force F intersects delta, so in this case the moment of force F is 0. It is quite easy. It can be seen from the picture I have already shown you some minutes before. Here, okay. Here, you see here, if I have the force F parallel to this axis Z, so the moment of force F above Z axis is 0. In this case, I have only force. Or here, for example, force F. If I want to calculate the moment above X axis, it is 0 also. Here, in this case, I have only the force moment of force F above Z axis. And here, if the force F intersects the axis X, Y, or Z, so it means that the moment should be 0. Okay? Okay, it is enough. And now come back again to this remark. And now I have one important remark for you. This remark because I see that many students read the Vietnamese textbook and sometimes you discuss the problem with Vietnamese colleagues in our university. Pay attention. In English or in Vietnamese textbook, all the time, in Vietnamese textbook, they define the moment M here like a scalar. You see from the triple product here, cross product give us a vector. And after providing dot product, I have a scalar. Okay, so and finish with the Vietnamese textbook. However, in English textbook, we can define this moment of force F above axis like a vector, as a vector. Why? Here, you see, I don't draw, I didn't draw the vector here. Like I draw here only the projection of MO to M delta, like a magnitude. It is like in Vietnamese textbook. However, look at this picture. What's this picture? You see here that after projecting here, I draw this component like a vector. Why? Because I have the magnitude after calculating dot product. However, in this axis, because I want to calculate the tendency of the body above this axis, I have this axis, I have the magnitude, I have also what? I have also the unit vector of this axis, so I can multiply this magnitude, it's a unit vector, so I can draw it like a vector. You see here, like here in this, at the first picture, I have already drawn it like a vector, but I didn't explain you at some minutes before because maybe it confuse you. But so you will remember well that M delta moment of a force above an axis can be defined as a scalar, and normally it is in Vietnamese textbook. But in English or in American textbook, all the time they can calculate or they can specify it as a vector because this magnitude, okay, this magnitude multiplied by unit vector of delta, so I can define it as a vector, okay, as a vector. Like here, you see here. After calculating triple product, so I multiply it by unit vector. So here it is in the bracket, it look like a magnitude of this vector, and the second one is a magnitude of direction of the vector. Okay, so it's enough for theory, and just now we calculate the first example with the moment of the force F above an axis. So you see this is your task for 5-10 minutes. We will do together, but you should do it yourself before I will go there, or we do together. Try to find the magnitude of the moment of this force above the axis. You see again the magnitude of the moment. It means that in this case it is enough if you calculate the scalar value. So do it. Make orientation. So you do together step by step. So plan. Oh, it is plan for you. Okay, strategy. Because I want to calculate the magnitude, so I use a triple product. So it means that I should find a f and unit vector also in the Mr. Tu, Mr. Chen Tu, here you are enjoying. Okay, it is not good. Even that, but I think that it is better to concentrate to the mechanics. Okay, like other people. Mr. Tu. Okay, I will remark here. Mr. Tu. Mr. Chen Tu. Okay. Very passive. Minus.
Sorry, teacher. Sorry, teacher.
Okay, come back again. It is very sad for me to see that you didn't enjoy. Okay, Mr. V, Mr. Anh, good. It is better. But pay attention to the significant digit, okay? It is for engineer. Again, so after finding f, after finding unit vector, because it is z-axis, so unit vector should be vector I, okay? And the vector R position from O to A. Yeah. It is something for you to calculating it. Oh, Mrs. Nhi, Thái Vũ Yên Nhi. It is Mrs. or Mrs. Nhi. It is what? It is Mrs. or Mr. What? Thái Vũ Yên Nhi. It is Mrs. or Mr.
Missy, sir.
Mrs. Okay.
Miss. I mean Miss.
Okay, not Mr. Missy or Mr. Normally you can say. So in this case, I think that we have in this classroom. This is also, so some ladies. Okay. Okay. So after finding it, so I use a triple product. Okay. Again with triple product, I have determinant with the 3 rows. Here I have a is a problem of the mathematics. So if somebody cannot follow it, so ask the problem or ask the friend or read again the textbook. Okay, it is not so. The first row is a unit vector of the axis. In this case, it is z-axis. Second row is a position vector. We have already calculated here. Okay. Third row is a component of f-axis of f fox. Okay, and after calculating again we have a positive result. It means that it is a counterclockwise of z of x. If I counterclockwise, if I look from the positive position, or you can use the counter the right hand rule for it is counterclockwise. Okay. Okay. So I see it is just we can take a break after finding. Like we do some more example about this one. Okay. But it is better to take a break. 10 minutes break. For somebody who cannot follow the problem, so look, I give this picture again. Xong rồi. Nặng không? Nặng đúng không? So let's continue. Okay, everything's okay. Let's continue. After finishing with some example, and now we go to the one more example, and after that we can go to the okay. Here, one more. Maybe in this case it is better for you. After finishing some example before, and this one is easier for you. Okay. We have a bracket with the angle alpha, beta, gamma. Try to find the moment of force F above axis AA. In this case, it is a parallel to y-axis. Parallel to y-axis. So try to do it. Try to do it. We can see how we can, after some guiding example before, so this one maybe is better for you. I hope that any clever student or hardworking student can be finished this one with a good example, a good result. Okay, now do it. Again, the strategy or the philosophy of this, it is quite similar to the example before. It means that I will use the triple product of F and unit vector of AA. Okay, so it is necessary to find a unit vector UA. It means that unit vector for axis AA. Also, position vector ROA, OA, okay, F and point O. And after that, you can use the three product. I should fix some point O, okay, like origin for specifying position vector ROA. So I should fit some point O on the line AA. And in this case, surely I have a unit vector UA. In this case, it is parallel to the original HO. Mr. Hoàng Việt Anh, good. You will wait. Mr. Tien too. Okay, you will see. You see, you have two first, but you see who has the correct answer.
Oh, sorry, teacher.
Okay, Mr. Usama.
No, I mean I'm Mr. Tien. Why is ROA by minus 0.1 I? I mean, I thought it must be 0.1. Why does have a sign minus?
ROA. Okay, because you fix point O is here. Okay.
Okay.
It is maybe X, Y, and Z. It is given coordinate system. However, ROA is you fix the another coordinate system. It is yourself by yourself. You choose. Okay.
Okay.
It's clear now.
Yeah,
Okay,
I'm clear.
okay, so do it. Good. Another result. Good. We are waiting. We are waiting. Okay, so here it is a component of F. Okay, again step by step we do together. But you see that at least here for some hardworking student, you have 3 different results. You will see. After that, you can use a triple. Okay, I show it again for some people who cannot join the. Here it is a component for necessary component for calculating. Okay. Unit vector, position vector, force vector, and after that I will provide triple product. The first row again it is a unit vector because it is of AA. So in this case you see that it is parallel to y-axis, so it is 0, 1, 0. The second one is a position vector from O to 8, and third one is a 3 component of force F. So you see, for some people, Mr. Tien, 2 times. Just know, I hope that you can see where you have arrow. Where have you arrow? Okay, and in this case, I have a positive one. It is counterclockwise. Okay, counterclockwise. And now, after finishing anything, okay, we will go to the what we have already said to you of some minutes before. Then we go to try to find after finding the 2 things: resultant force, resultant coupler, or resultant moment. You will go to calculate these 2 things, and it leads to the resultant moment. The second very important characteristic of the force system. You see again, I have many forces. F1, F2, F3, and I fix some point here. And it means that from this force system, I can calculate the moment of all forces above this point and provide summation, and it is so-called resultant moment of system of forces. Okay? Remember well this definition. And here is one remark, because in all the textbook, they all the time they repeated it Varignon theorem. They say something that moment of a force above a point is equal to the sum of the moment of all forces, or all component forces above the point. Why it is important? It means that it is it means that I have so many forces, and I want to calculate the resultant force. So in this case, Varignon theorem says that the resultant, the moment of resultant force should be the same like the moment of all forces, or vice versa. If I have the one force, I can explode it into many components. So in this case, the moment of the original force is equal to the moment of all components of force above this point. Okay, so maybe somebody saying that it is clear, and also, however, I repeat it again here because sometimes if you go to some further theory part, and somebody asks it is valid or not, so I repeat it. So okay, like here, for example, I have 2 forces. I have 2 forces. I have F1 and F2, so you can use a parallelogram, okay, or find a resultant force. Resultant force F, and I calculate the moment of this force above point O. So it should be the same like I calculated the moment of force F1 and F2 above point O. Okay. Okay. So you see that if F is equal F1 and F2, so the moment of MO of F and the moment of F1, F2 is the same. Here it is the proof. If I have the calculated moment of these two foxes, so it gives F in this case it is a resultant fox. It is so-called Varignon theorem, remember, okay? And next to the beside of the resultant moment of system of all foxes. And now we will go to the one portion more. Special case of fox system. If I have two foxes which have the same magnitude and they are parallel and they have opposite direction. So in this case, I say that it is a couple. That is a couple. And in this case, the property or the effect of this special case of this fox system is quite interesting. Like if you imagine the driver of the car and he has the volant or the driving wheel, so you see that the driver can keep the volant in with two hands in some way, in very with the two hands too far or too close, okay? And you see that if they keep with too close, with two hands too close in the volant, so in this case the fox should be bigger. However, if I keep it in the farther distance, so in this case the fork can be very small. So in this case the effect of this coupler is very special. How I can define it? I can calculate the moment of this coupler by calculating the moment of each fox to a point and provide a summation. So you see here, I have two foxes, F and minus F. And here I fix some point M here, O here. So I calculated the moment of a fox, F above point O. This fox has the point of application, for example, point A. And I calculated the moment of fox minus F with the point of application B above point O. Okay, so I have M AR times F plus B time minus F. And after taking F out of the F, so I see RA minus RB. Here it is vector R. The result it is quite easy, quite nice, and quite interesting. M is RF. What is a vector R? R is any arbitrary vector from one point of in one line of application to the second line point on the second line of application. Vector R. Look at this. And R times F. It is quite interesting. And also, if I using cross product of these things, so I have R times F times sine theta. What is this? It is D, distance here. R sine theta is FD. So the result, it is more interesting. It means that the coupler or the moment of this special case of fox system is only F time distance of these two foxes. So it illustrates or proves what I have already said some minutes before. If these two foxes are in the bigger distance, so the coupler should be the same if F is smaller. And if these two foxes are closer and closer, and if I want to have the same coupler, so the fox should be bigger. Okay, so it is a very nice thing. Either in the scalar or algebraic definition or calculation, or using this vector vector representation. In vector representation, you can see that it is very nice. That I have two foxes, it creates a coupler, and I can create the moment of this coupler by one vector. This vector has a magnitude of F times D that I have already shown some minutes before. And this has the magnitude of FD, but the direction is perpendicular to the plane containing these two foxes. Because I have two parallel lines, so I can construct very easily the plane and draw perpendicular line. Okay, magnitude, direction. Where is the point of application? You see that point of application, it can be anywhere, Okay, oh, this vector can be kept only that it should be parallel to this direction. So in this case, I say that the moment of a coupler is a free vector. Okay, that this free vector can be applied at any point at the body, because you are speaking about Fox system theory. Okay, so pay attention that this coupler has a free vector. It means that I can move this vector anywhere, only the magnitude and the direction unchanged. It is very nice thing. Okay, so there are some characteristic of this coupler. You can do it because I can imagine, I can use this vector by any vector perpendicular to the plane of the forces. So you see that the vector can be anywhere. So these two couplers are equivalent if they can be represented by the same vector. Okay, the same vector. So it means that I have two couplers are equivalent if they are magnitude should be the same, fd1 times fd2. Oh, here, like example, you see it is a two picture. Either they have other direction, however, all the time the direction of coupler vector should be the same, perpendicular to this plane, but the magnitude should be the same. F1 times d1, f2 times d2 should be the same, and they can be in the parallel plane, and the sense of the direction should be the same. It means the tendency of the rotation of the body or the plane should be the same. Okay, it is one property. The second one, because I use the vector operation. So in this case, you see that I can use it advantage of many operation. For example, addition of coupler by using, for example, one coupler here, F1 and F2 here, F2 and F2 minus F2 here. So there are many ways to do it. You can calculate the resultant force of these two points, and after that create a resultant coupler, or by using the M1 and M2 by representing these two coupler by vector, and after that I calculate the resultant coupler of two original coupler. So you see, it is only some mathematical operation for you to understand well. So resultant coupler, if I have many forces, I can calculate resultant coupler of many coupler and many forces. Okay, so here it is a very nice thing also, step by step, to see what we can do with the vector representation of the coupler. Look at this picture, the first picture. I can have the coupler, which is represented by two forces. So in this case, I can draw the plane. Okay, I can calculate the magnitude by F times D. So this one is equivalent or can be represented by one vector. This vector is perpendicular to the plane, okay, with the direction following by right hand rule with the direction of rotation, and the thumb will show the direction of the vector magnitude FD, and point of application in anywhere. Okay, Well, these are two things. This thing is and this two picture are quite easy for you to understand. But the nice thing, once more, even it's here, but because I say that the vector of coupler is a free vector, so I can move this vector from here to the origin. Okay, because it is free vector, but the direction and the magnitude should be the same. So I can move here from any point from this point from this plane to the origin of the coordinate system. It's a nice thing. It is quite interesting for many people. And one thing more, with this vector, with the Cartesian coordinate system, I can explore it. I can explore it. I can explore it. So in this case, into three components: fx, fy, and mx, my, and mz. So you see, very nice thing that at the first picture, I have one coupler and this coupler. So in this case, I have three components in the moment fx, fy, fz. Okay, do you understand? Okay, so I see that some question from Mr. Tien. M thay A, F1, FA, but in this
No,
case,
so I'm sorry, that's my mistake.
my mistake. Okay, you look. It is a vector. It is vector. Okay, it is not like algebraic no zero. So okay, it is a mistake. Good. For somebody, if you can enjoy, maybe the question of your colleague, maybe it is a question for you also. It is good that the student all the time can pose some question. For somebody, for clever student or for the hardworking student, all the time, if they can pose the some question, surely they are able to find the answer. Good that you have the question. Okay, step by step, it means that your knowledge or your way of thinking go ahead, step by step. Good, Mr. Tien. Okay, so it is some look at these four picture and remember well, and this is give you some nice presentation of anything. Now look at this example, last example today. After that, you have some comment. It is not look at like simpler, but it is a very closer. It is near to the problem in your future engineering career. You have some beam. You have some beam here. You have some fork here. Some cable. It means that this fork F and minus F create some coupler, and these are two forces, 2 kilonewton, 2 kilonewton, give also some coupler. So I have two coupler up at the beam. And surely under action of these two coupler or four forces, this beam will deform. But in this course, we don't say anything about the deformation. We only say that possible this beam is stiff enough. Okay, it is stiff enough. It means, and try to find if for example the director or other engineer said to you that the resultant coupler is 1.5 is enough if I can design the beam. So try to find the magnitude of force F if resultant coupler moment is 1.5 kilonewton. Okay, so make orientation and we'll do together in the more than 10 minutes later. So at first, take orientation, think about this, find the way to calculate it, and after that we will do together. Lúc nào nó quên bật cái cam lên thì xong. Okay, sis. Camera. Okay, we will have plan. First thing, because I have two Kepler. So in this case, I will calculate the resultant Kepler, and after that, because I have a one Fox F, not in in numerical value. So after that, I'm equating it, and then I can find Fox F. Okay, do it. You are waiting. Another duty, many works. No answer. This example is not too complicated because you have 2D problems. So in this case, the vector analysis is not necessary. You can use a scalar analysis to calculate it. Thought. Mr. Hoàng Việt Anh, Mr. Mr. Đạt, these two people are very active. Mr. Nguyễn Tấn, what is this? Okay. So the moment of two couple type FD, because I say that this one you can use the scalar algebraic analysis. So the first couple is F time distance between them, and the second one 2 time distance between them. And after that, I equating it with the minus 1.5 kilonewton meter. And after equating that, I can get very easily F equal 2.33. Okay. Oh yes. Maybe it is too simple, so I don't see that many students to give the answer on the chat room. Okay. So after finding this, you can go to the most important thing of anything. Next time we will explain more. However, at this moment, for preparing, for reading at home, for understanding why we have done last week and next week, very long explanation why and what and do it, you see that here is a conclusion. Next time we will explain it more. It means that for any complicated Fock system, you can replace it by only two things. First thing, you see, look at this picture. For any Fock system, I can replace it by one Fox, FR, resultant Fox, and resultant coupler. Here, in mathematical way, you see that I have many Foxes and many coupler. Oh, coupler, I can see that for each coupler, it is a system of small system with two Foxes. But sometimes I separate it. I have many Foxes and many coupler. For any this complicated system, I can replace it by only one resultant Fox acting at 1.0 and moment one resultant moment above 0.0. So you see, resultant Fox FR is a summation of all Foxes, but with the point of application at 0.0. And all moment here is the summation of moment of coupler, and moment of Fox F. Okay, how we can do it? You can see here. Later I explain it. It means that here I have many foxes and many coupler. And each fox, I will remove it. I will move it from here to point O. So later you see, and I move it here. So I have one fox and one coupler. You see here, one fox F and one coupler. So it means that after moving anything, I have two systems. One system of all foxes acting above point O. And second system is a system of many coupler, many moment. And from the previous week, from the previous lecture, you know that for any concurrent foxes, I can replace concurrent foxes by only one fox, it's FR, and it's passing through point O. And the second system of many coupler, I can find by only one coupler. So you see, really, I have only one fox and one coupler. And now, after have any fox system reduces to these two things, one fox, one coupler, I can be able to answer to the question whether this system, this rigid body is in equilibrium at rest or will move. So you see, I have equilibrium, or other thing, or maybe by one fox or by one coupler or both. So it means, but these three cases list the body to the motion. Only the first one is equilibrium. Okay, so it is the topic of the first semester. For other three things, it is preparing for the other the second course. It means that it's motion. Okay, so next time you will explain it more. But for reading at home, so you can see that why we have done in these 2 weeks that any complicated fox system can be reduced to one fox and one coupler. And with these two things, we can discuss about the state of the motion, either in equilibrium, at rest, or in the motion, really. Okay, next time. And now for some minutes, for 4 or 5 minutes, rest. You will read something, homework. First thing, read the textbook. I have already posted on the team the textbook in chapter 2, so you can read it for 2 weeks, last week, this week. But you can start with the reading, with the reduction of the fox system for catching next time. It is you can understand well my lecture again. And after finding it, it is one thing for understand why, so deepen your knowledge. But it is very important that you should do many problems on the textbook. I don't know if you can go to the library to borrow the book, but also I have already posted on the team. You have it, you can do it. Many students, not so many, okay, have already sent me the problem, and somebody asked that if they have sent so many examples. Somebody clever and hardworking students send all 14 examples. It is good, but I don't say that if you think that it is enough, you can choose some example for understanding the problem. Okay, I don't say anything that you should do each example this one or this one. It is important that for you that you understand when the problem and discuss the problem with your friend. Compare the result. I didn't give you any result. Didn't give you any result. Only after discussion with your friend, you cannot find the consistent as the same result. Only this case, ask me via email, okay, or in the classroom. If or you can ask some problems. Please, professor, send me explain to me some. And if the programs are too short, I can write to you. But normally, if you need more time, so at the beginning, at each session, I will explain to you. And one thing very important, please, If you send the problem to me, send me to my email or send the answer question also. Don't send to the chat room, because I have many other duty, so I don't have not so much time, and I answer your email in my free time. Okay, so send to my email, to the university email. And when you send the problem, so please send me only one file, not too much. Today in the early morning, I check. Last night I didn't see, but somebody sent me, for example, 6 and 5 picture. It is it take me too much time. Please send me only one file. It save me time. Okay, I don't have not so much time. And in file and in your email, please specify your name. Student ID is not necessary, because nobody has the same name. So you have a name and your class, because we have 2 classes. This class is 1, 2, 8, 4, 62. Okay, 62. So please classify your name, class, and the number of the program. For example, 2.1, 2.2, 2.3, and 2 and, for example, 2 and 50 or so. Okay. So, but remember, when I send me only one file, save me time and effort to do, because I have many other duty. Okay. I hope that it is enough and you will enjoy. You can, if it is necessary. Any question? Any question? Oh.
Can you give us the slide after this question?
Who have this post this question? What you say that I should post this slide? Okay, Mr. Who asked Mr. Tien or not?
Yeah, it's me.
Okay. Did you join the team last week? I have already posted the slide. So for the first week, and the second save the way, the same way. Okay, so I think that you
Right.
didn't. Okay, so okay, if not, so see you again.
What about the deadline of the problems?
So see you again. Okay, so see you again. I think it is a deadline. All the time, the problem for you, you do the example. It is for you, not for me. Okay, I only check if you have active or not. Okay, so don't think that it is important for me. It is important for you. Okay, okay, because each it is better for you that each week you should do something, because you should follow whole the course. Don't let the time that at the before examination you do, it's not enough time to understand well. You cannot capture example the my lecture. Okay, so if not, so I, because it maybe somebody want to see me, I will show the I stop the sending, and I show it. Maybe somebody can see me. So Q, if no problem, no question, so see you again. Okay, next time.
Bye.
No, bye. See you again. Okay.
Bye.
Bye, sir.
Bye, sir.
Yes, sir. It is better. Again, I say to see you have some problem with English, but for example, very common mistake. If you go somewhere to America and Europe or something, don't say teacher, because in Vietnam, Vietnamese language, all the time you say thưa thầy, it is good way. But in English, don't say teacher. You say yes sir or dear professor or something like that. Don't say teacher. Okay, it is I don't know where in the English course they say to you. If you go to Europe or you say to some guide from the at university, all the time call it, for example, doctor. Yes sir, yes doctor, yes Mr. or you can say the name Mr. Fong. or Professor Phong. Don't say teacher. Okay. Okay. So it is one thing from the English course for you. So okay, see you again next time.
Yep.
Yes. Okay. See you.
Goodbye, sir.
Yeah. Goodbye. Good. Goodbye. See you again.